Greetings, members, one and all of the Salivation Nation. Silver used with this metal can stop CO2 emissions. Let's explore! What you're looking at here is a silver round with a Bohr's diagram on it. And this is probably the best example I can find that shows the science and nature of what a silver is all about. This happens to be the original Salivate Metal round here that was produced some time ago. But we're talking about how silver can connect with another metal to stop CO2 emissions. And this is a fascinating find. And it is based off of an article from Australia. Engineers from UNSW have helped to discover a cheap and new way to capture and convert CO2 greenhouse gas emissions using liquid metal. The process can be done at room temperature and uses liquid gallium. That's right, liquid gallium, to convert the carbon dioxide into oxygen in a high-value solid carbon product that can later be used in batteries and or construction or aircraft manufacturing. Gallium is the metal that can be used. A team from the School of Chemical Engineering, led by Professor Kourosh Kalantarzadeh, worked in collaboration with researchers at the University of California, Los Angeles, North Carolina State University, and others. Their findings have been published in the Advanced Materials Journal, and Professor Kalantarzadeh and his team say that the new technology has the potential to be used in a wide variety of ways to significantly reduce the levels of greenhouse gases in the atmosphere. And I'm going to stop right there because you're probably wondering what the heck this is right here. This is actually gallium. And gallium is a metal that has a melting temperature of 86 degrees. And this example is 3/9 fine gallium and was sent and cast for me from Cyber Curtain Twitcher. And this is an example of what it looks like in its solid form. But in order for this technology to work, well, it would have to be liquid metal, which means it would have to operate in an environment that is almost 90 degrees. The article continues that we see very strong industrial applications with regards to decarbonization. This technology offers an unprecedented process for capturing and converting CO2 in an exceptionally competitive cost, says Jun Ma Tang, the first author of the paper. The applications could be in cars to convert polluting exhaust gases, or even at a much larger scale at industrial sites where CO2 emissions could be immediately captured and processed using this technology. Now the question is will that pose a threat to platinum as a catalytic converter for catalytic conversion? We have already scaled this system up to 2.5 liter dimensions, which can deal with around 0.1 liter of CO2 per minute. And we've tested that running continuously for a whole month, and the efficiency of the system did not degrade. So that is fascinating. Usually catalytic converters tend to over time, even though the actual platinum and palladium used in those itself does not degrade. The newly discovered process dissolves captured CO2 gas into a solvent around nanoparticles of gallium, which exist in liquid state above 30 degrees Celsius. The reactor also contains nano-sized solid silver rods. That's right, solid silver rods. And those solid silver rods really do a number, and they are key to generating the triboelectrochemical reactions that take place once mechanical energy is introduced. A triboelectrical chemical reaction occurs in solid-liquid interfaces due to friction between the two surfaces. So yes, indeed, these two surfaces, is there any friction? Do we see any? They seem to be pretty harmonious between these plastic cases. no friction between them right now. But nonetheless, yes, pretty fascinating to see how that technology can work. It creates an electric field that sparks a chemical reaction when those two metals are together. The reactions break the carbon dioxide into oxygen gas as well as carbonaceous sheets which float to the surface of the container due to differences in density and can therefore be easily extracted. So in their paper, the research team show a 92% of efficiency in converting a ton of CO2 as described using a low energy input. They estimate it equates to a cost of around $100 per ton of CO2. So in order to commercialize the research, a spin-out company called LM Plus has been established with the support of UNSW's Knowledge Exchange, a program that helps transform research discoveries into successful innovations to benefit society, along with seed investments from Uniseed. UNSW has become a shareholder and part of a license agreement with the company. It's pretty exciting to see they were able to prove this. It's a very green process, which also produces a high-value carbonaceous sheet, which can then be sold and used to make electrodes and batteries, or for carbon fiber materials that are used in high-performance products like aircraft, racing cars, and luxury vehicles, said Paul Butler, Uniseed's investment manager and director of LM Plus. What we are working towards now is to raise funds to build a larger size proof of concept for this system to work within a 40-foot container, the size of a truck trailer, that could ultimately help industrial sites immediately capture any CO2 emissions and convert them. LM Plus hopes to be able to build that much larger system within 15 months and is already in talks with potential commercial partners about other ways to implement the new technology. So the reason why this is important, folks, is because for the first time we are seeing silver aid in the process of catalytic as a catalyst. Obviously, it'll work in tandem with this metal, with gallium, but nonetheless, it is exciting to see how these metals can work together in order to help curb these emissions. Now, I will say this, that I'm not necessarily one of these that believes that man caused participation in man is the one single cause for global warming. We know global warming exists, but I believe a lot of it occurs by natural phenomenon. But nonetheless, I believe that if there are ways to be able to reduce some of those emissions, hey, why not? Especially if they can be done cheaply and effectively. After all, once it became viable, economically so, I actually purchased solar panels for my home. And they have proven invaluable economically, and obviously they have contributed to being a clean energy source, at least after the solar panels were produced, because it does take a lot of carbon, a lot of oil, a lot of energy to actually produce solar panels. So once they're produced, and then it's a matter of having them work back in order to make up for that production cost or production energy output, production carbon credits, so to speak. But this new technology may help to curb some of that for future solar panel creation down the line. But nonetheless, there it is. This is an example of gallium, and I've never actually touched this or melted it down. As you can see, this is in the exact state from which it was sent to me by Cybercurtain Twitcher. But it is neat to have this in my stack, and but nonetheless, there it is. Maybe one day I'll play with it. But it is liquid metal, and that's why you see it there, and it's not quite, it's a pretty sharp little contrast there, and actually CCT gave me a mold that I can use to recapture this after I play with it. But nonetheless, there it is. Let me know what your thoughts are in the comment section below about this technology, and that's one thing I do like to do in this channel, is talk about how science relates to silver and gold and other metals. And such as the case today, it happens to do with silver and gallium. a multitude of gratitude to you all for taking the time to watch. And I want to encourage you to please rate, share, comment, and subscribe.